Okay, so we're going to look at our example now. First example from the thing. We got example 1 from the textbook. So what it wants us to do is prove that the equation sine of x equals 0.3 has at least one solution. Okay. So what I'm going to do is I want to use the intermediate value theorem. I know sine of x is continuous. What I need is I need a y value for sine that's smaller than 0.3 and a y value for sine that's bigger than 0.3. And I can use those as my endpoints of my interval. So let's do a little bit of setup stuff, and then we'll try to write stuff cleanly. So sine of 0 is equal to 0. So I know for the x value is 0, the y value is 0. Sine of pi over 2, pi over 2 is 90 degrees, so sine of pi over 2, that is 1. So I'm going to use this because 0.3 is between 0 and 1. That's why I'm choosing the interval 0 up to pi over 2. I could choose a different sine value here that makes me 1, or I don't necessarily have to go up to 1. If I could get like, sine of square root of 3 over 2, let's see, is that right? Let's see what square root of 3 over 2 is. If that's bigger than 0.3, we could use that as well. Let's see, 3 square root divided by 2. And no, I'm wrong. That's way on. Wait, no, that's over 0.3. So yeah, we could use any of the sine that have square root of 3 over 2 as their y value, and that would work because from 0 up to square root of 3 over 2, 0.3 is in between those. But 0 and 1 are kind of easier to work with, so we're going to say 0.3 is between 0 and 1. So there should be a way to set this up using the intermediate value theorem. So what we'll do is we'll say sine of x is continuous. It's continuous for all real numbers, so it's continuous all over the specific closed interval of x values 0 up to pi over 2. And again, I'm choosing those x values 0 and pi over 2 because they lead to y values 0 and 1, and 0 and 1 are on either side of 0.3. So we say, okay, we got the f of x is continuous on a closed interval, and we need f of a not equal to f of b. So we'll say, and sine of 0 equals 0, which is not equal to sine of pi over 2, which equals 1. So we're saying the starting value here, sine of 0 is 0, sine of pi over 2 is 1, and those two are not equal. So from our intermediate value theorem, we showed that this is true. So then, for every m between f of a and f of b, there exists at least one value c, such that f of c equals m. So we'll say then, as 0.3 is between, we'll say sine of 0 equals 0, so sine of 0, and I just want to make it clear what the y value is, and sine of pi over 2, which equals 1. So we can be clear that 0.3 is between 0 and 1. So I'm writing the y values out there so it's very clear that 0.3 really is, it's between 0 and 1. So as that's true, then by the intermediate value theorem, so we'll say by IVT, there exists, let's scroll back up and just read it again. So there exists at least one c in open interval a to b such that f of c equals m. So there exists at least one C element of open interval 0 up to pi over 2 such that sine of that particular C value is equal to 0.3. And then we're done with what we needed to do. So we wanted to prove that the equation sine of x equals 0.3 has at least one solution. It didn't tell us to find what that solution is, it just said show us that we had at least one. So we did a little setup and we got, hey, here's two x values that for sine generate y values that are on either side of 0.3. And then we started using the intermediate value theorem. We said, hey, sine of x is continuous everywhere. It's a basic function from the 2.3 theorem. So it's continuous on 0 up to pi over 2. And we note sine of 0 is 0, sine of pi over 2 is 1. They're not equal. So we can apply the intermediate value theorem here. We get then as 0.3 is between sine of 0, which is 0, and sine of pi over 2, which is 1. So 0.3 is between 0 and 1. Then by the intermediate value theorem, there exists at least one C in the open interval 0 up to pi over 2, such that sine of that C value equals the in-between number. And that's basically how we use intermediate value theorem.